Seminometrics combines semiconductor science and technology, which focuses on designing, developing, and manufacturing semiconductor devices, and Econometrics, which applies statistical and mathematical methods to economic data to test hypotheses and forecast future trends. Seminometrics focuses on analyzing the economic aspects of the semiconductor industry using econometric techniques. It includes studying market trends, investment patterns, production processes, and the global impact of semiconductor technologies. Let us break down the core components of Seminometrics. Market analysis involves understanding trends, demand, pricing, and competition in the semiconductor market. Investment and finance analyze investment patterns, financial performance, and funding in semiconductor companies. Production and supply chain examines cost structures and economies of scale and optimizes supply chains. Policy impact evaluates the effects of government policies on the industry. Innovation and R&D measure returns on research and development investments and their impact on growth. Labor economics studies employment trends, wage dynamics, and the impact of automation. Global trade investigates trade flows, comparative advantages, and trade policy impacts. Environmental and social impact assesses the economic and social implications of environmental regulations and sustainability initiatives. So, why should students learn about Seminometrics? By studying Seminometrics, students comprehensively understand a crucial industry's technical and economic aspects. They will be equipped with skills to analyze market trends, evaluate financial investments, and understand the global impact of semiconductor technologies. This interdisciplinary knowledge is precious, preparing students for careers requiring technical expertise and economic insight. How can universities effectively teach Seminometrics? Start with an introduction to semiconductor technology, covering basics like material science, chip design, and manufacturing processes. Next, provide a strong foundation in economics and econometrics, emphasizing data analysis, statistical methods, and economic modeling. Using real-world case studies, introduce students to market dynamics and financial analysis specific to the semiconductor industry. Incorporate lessons on the impact of government policies, global trade, and international regulations on the semiconductor sector. Focus on innovation and R&D, teaching students how to measure and analyze the returns on these critical investments. Finally, practical applications and case studies can bridge theory and practice, enabling students to apply their knowledge to real-world scenarios. By integrating Seminometrics into the curriculum, universities can play a pivotal role in preparing students to address the economic challenges of the semiconductor industry. It, in turn, can drive innovation, foster economic growth, and contribute to the industry's continued success. Embrace Seminometrics to stay ahead of technological and economic advancements, drive informed decision-making, and foster sustainable development in the semiconductor sector.